Hello, my name is Leeshan Mahadeo, and my presentation is about the management of harvest residue. In this presentation, I will share the aims and objectives of the recently completed Zululand trial and its preliminary results. In addition, I would introduce the follow-up trials planned for KZN. By way of introduction, I just want to show you these images of a mulch compartment versus a burn compartment. And we can notice the variable difference between these two compartments. My project will look at the costs and productivity of mulching, as well as the effects of mulching versus burning on pitting and planting productivities. This slide depicts conventional sequential re-establishment cycle of events, from site preparation up to planting. It includes the burning of slash prior to pitting or planting. In many cases, burning cannot occur immediately after harvesting. So, due to climatic factors, this hence delays the operations and adds significant risk in the delay in the cycle as a whole. This slide shows the same rotation as the previous one, but the difference here is that we have eliminated the burn window as we replaced it with mulching. While mulching can be planned ahead of time and is done immediately after harvesting. There are also other important benefits around mulching. One is accessibility into the plantation, and the other is the role that mulch plays on moisture management. There are two trial sites, one at Kwambo Nambi in eucalyptus and the other in Bulwer at the KZN Midlands area in pine. Initially, there was a site planned at York Timbers in the Highveld, which we hopefully will continue with at a later stage. The aim of the study is to assess the application of mechanical mulching of harvest residue and its effects on the subsequent operations such as pitting and planting. The methodology that consists of this assessment is the assessment of the remaining biomass and stump volume using the line intercept method and basic stump measurements. A subsequent time study of mulching, pitting, and planting operations are done, and it's also important to note that SAPI applied a no-burn policy. So close assessment of burning and mulching could not be done directly in the Zululand area. These are two images taken 8 months apart, illustrating the progression from immediately after mulching of the same compartment and where pitting commenced directly after the mulching operation. This assessment was conducted on two compartments, J31A and B, and both of them are situated in Kwambo Nambi. And the reason why we selected these two compartments was due to the fact that they were going to be mulched within a relatively short space of time. And here we show you a table with background information of these compartments, where full operational studies of mulching, pitting, and plantings were done on the same compartment, except for planting operations in J31A, where K19 was used as a proxy. Harvest residue, which includes tops, branches, and offcuts, was assessed using the line intercept method, and stump residue were calculated through a zigzag sampling method. This table is a combination of stump and residue volume, giving us a total stump and residue volume per compartment. If we look at the results, compartment J31A 60.6 cubic meters per hectare, and J31B 36.4 cubic meters per hectare. As we note that there are differences in these volumes, and we look deeply to see where does the difference come from. Looking at the residue volumes, we see that J31A has a highest residue volume compared to J31B. The mulching time element was recorded on the Saviti's cat mulcher equipped with a FAE mulching head. It was observed that the mulcher did 2 passes per a swath to achieve this good quality mulch. And the time elements recorded were mulch and turn. The time study results shows the following. If you look at compartment J31A and B, these compartments have very similar productivities with an average productivity of 0.38. It's important to note that even though compartment J31A had a higher total biomass compared to compartment J31B, the productivities are quite similar. And this shows that the results of the productivity of these machines aren't affected, most probably due to the fact that the machine has significant mechanical capacity to deal with these loads. Moving on to standardization. Here, to standardize the mulching productivity, the mulching time per 100 meters were calculated. And standardizing helps us better compare productivities since compartment has different swath lengths. And an average of 4.13 minutes per 100 meters were observed. Moving on to the turn time, an average between the 2 compartments was 0.31 minutes per single turn. Holistic view of the time consumption of mulching operations, we see that mulching consumes 98% and turn 2% of the total productive machine time. Pitting operations were done by an impact excavator-based single-pit pitting machine, and this was owned by contracting company Zululand. I observed that the machine made 8 pits per cycle, and the elements that were recorded were pit, move, and turn. Both compartments appears to have a similar result with an average of 0.26 hectares per productive machine hour. Moving on to the turn time, here we see that the machine takes about on average 1.55 minutes to complete a single turn. As far as time allocation to elements are concerned, pitting consumes 86%, move 12%, and turn 2% of the total productive time. This study was based on Zululand's tractor drone planter equipped with 2 1,500 liter water tanks and 7 planting tubes. The time element that was recorded were plant, turn, and fill. Both compartments, K19 and J31B, has quite similar productivities, with an average productivity of 1.79 hectares per productive machine hour. Moving on to the fill time, here you see both compartments have very comparable fill times, with an average fill time of 28.58 minutes. Turn time has an average of 2.45 minutes per single turn. As far as time allocation goes, planting consumes 64%, turn 7%, and fill 29% of the total productive time on planting. Moving on to our next research site, which is Bulwer. In this trial, we'll concentrate on pine, where we'll replicate the burn and mulch parts of the previous trial, but here we will add a chopper roller into the equation. Expected outcomes for my project. Firstly, we'll be simulating the influence of mulching on reduced temporary unplanted areas, looking into updating productivity and cost information involving mulching, chopper rolling, mechanized pitting, tractor drone planting operations. We'll be looking into methods for quantifying and classifying mulch qualities. And lastly, improving the assessment of residual biomass, looking into the quality and quality through drone imageries. Thank you for taking the time to listen to my presentation. I'd like to give special acknowledgement to my funders York Timber and SAPI, and also the contractors and foresters that helped me plan and execute my trials.